If you're a React developer, you're already using hooks every single day. But today, we're not just going to talk about syntax, it's about really leveling up how we think, seeing hooks through the eyes of a senior architect. We're talking about trade-offs, performance, and the mental models you need to build truly robust applications. So let's get into it and start rethinking the tools we use all the time.
Seriously, I want you to pause and think about this for a second. Yeah, you know the syntax for useState and useEffect, no problem. But are you really thinking with them? Are you using them to orchestrate complex systems? To keep your UI perfectly synchronized with the world outside of React? And that is the leap we're about to take together, from simply using hooks to truly thinking with them.
Okay, check this out. This one slide really nails that shift in mindset. You know, a more junior dev looks at useEffect and thinks, okay, this runs code after the component renders. Simple enough, right? But a senior architect, they see it as a tool to synchronize a component with an external system. Think about that. We're talking about the browser DOM, a network request, maybe a live WebSocket. It's not just some lifecycle hook. It's this powerful statement about keeping things in sync.
Okay, so first things first, let's dive back into the hooks we think we know inside and out. We're going to peel back some layers here and find not just the hidden power, but also some of those sneaky traps that, honestly, even seasoned devs can fall into.
You know, automatic batching in React 18 is one of those features that's just a huge deal, but it works so well you might not even notice it. Before React 18, if you had 2 or 3 setState calls inside a promise or a timeout, you were kicking off a re-render for every single one. Bam, bam, bam. But now, React is way smarter. It just bundles them all up into one single, clean, and efficient update. It's a huge win for performance that you get for free. All right, let me give you a couple of pro-level tips for useState that you should absolutely have in your toolbox. First up, lazy initialization. Let's say you have some really expensive calculation to get your initial state. Instead of just running it, you just pass a function into useState. Why? Because React will only run that function one time on the very first mount, not every single time the component re-renders. Second, and this is crucial, is object identity. Remember, React needs a new object, a new array, a new reference to see that something has changed. It's why just pushing into an array in your state doesn't work. You have to give React a brand new box for it to realize anything is different.
Okay, listen up, because this is probably one of the most common and frankly dangerous anti-patterns I see with useEffect. You get an infinite loop, and to fix it, you just delete something from the dependency array. But you haven't fixed anything. What you've actually done is told React to lie. You've created what's called a stale closure, where your effect is now using old, outdated values from a previous render. It creates these bugs that will drive you absolutely crazy. Don't do it. Find the real reason for the loop and fix that instead.
Okay, let's break down a classic race condition. I guarantee you'll see this concept come up in senior-level interviews. So here's the play-by-play. Request A kicks off, but whoops, before it's done, a prop changes, and that triggers a brand new effect, starting request B. Now here's the kicker. What if request A, the old one, finally comes back after request B is already finished? Boom! You've just slapped stale, outdated data all over your UI. This happens all the time in the real world.
So how do we fix that mess? Well, here's the pro move. The magic is in the useEffect cleanup function. Think of it like a little janitor that runs before the next effect starts or when the component unmounts. Inside that cleanup, you can use a modern abort controller to cancel the fetch, or even just a simple Boolean flag. Then, when your fetch finally resolves, you just check that flag before you dare to set the state. If it's been canceled, the old response just gets thrown away. Problem solved. Your UI stays consistent. All right, next up, the performance playbook. This is where that architect's mindset really comes into play, because it's about knowing not just how to optimize, but when. And maybe even more importantly, when not to. It's all about making smart trade-offs.
All right, let's clear this up once and for all. Use memo versus use callback. Use memo memoizes or saves the results of a function, the final value. Think of a really heavy calculation. Use callback, on the other hand, memoizes the function itself. But here's the warning. Don't just go wrapping everything. Sometimes the cost of all that memoization is actually more work for React than just rerunning a simple function. You have to be intentional about it.
And if you remember one thing about use callback, make it this. It's almost never about the performance of creating the function itself. That's super fast. The real reason you use it is to maintain something called referential equality. By wrapping it, you're guaranteeing that child components get the exact same function instance on every render, and that is what allows React.memo to work its magic and skip re-rendering those children when it doesn't need to. It's all about preventing unnecessary child renders.
Okay, The timing of these different effect hooks is absolutely critical. Let's look at the timeline. First, for things like CSS in JS libraries, useInsertionEffect fires before React even touches the DOM. Then, React actually mutates the DOM. Immediately after that, but before the browser actually paints anything to the screen, useLayoutEffect runs. This is for when you need to measure DOM elements. And finally, after the user sees the visual update, the normal asynchronous useEffect runs. This is why 99% of the time, useEffect is the one you want.
So most of us learn useRef as the hook for getting DOM elements, right? But that's only half the story. The real power of useRef is that it's just a mutable box. It's this little container that can hold on to any value you want across renders. And here's the key. Changing it does not cause a re-render. It's perfect for things you need to keep track of, like timer IDs or maybe the previous value of a prop.
Okay, let's step into the really modern stuff now. React 18's concurrent features. These aren't just minor additions. They fundamentally change how we can build UIs that feel incredibly fluid and responsive. They're all about solving those really tricky UI challenges that used to be a total nightmare to fix.
Oh man, we've all been here, right? You're typing in a search bar, and with every single letter, the whole UI just freezes. It feels janky, it feels broken, all because it's frantically trying to filter some giant list in the background. This is the exact problem that concurrency was built to solve.
And the solution is useTransition. It's this brilliant hook that lets you basically tell React, hey, this state update, it's not urgent. Take your time. So React can keep the urgent stuff, like you're typing in the input box, super responsive, while it works on that heavy list filtering in the background without freezing the UI. No more jank, it just works. But this new concurrent world introduces a really subtle problem called tearing. Imagine React is right in the middle of a big non-urgent render, and suddenly your external state manager, like Redux, pushes an update. What can happen is that some of your components render with the old state, while others render with the new state. You get this bizarre, inconsistent UI where it looks like it's literally torn in half.
And thankfully, React has an official fix for this. Use Sync External Store. It's a hook that's basically a handshake between React and external stores. It forces those updates to be synchronous, which guarantees that your entire UI is always looking at the same, consistent version of the state. No more tearing.
Okay, let's bring this all home and talk about the architect's mindset. Because being a senior dev and architect, it's not really about having every single API memorized. It's about a total shift in how you approach problems, moving from just writing code to making really smart, deliberate trade-offs.
And a huge part of that mindset is looking ahead. React 19 is bringing some amazing new tools. There's useOptimistic for making UIs feel instant, useActionState, which is going to make handling forms so much simpler, and the new useFunction, which is a total game changer for reading data. The point is, the landscape is always changing, and a senior mindset means keeping up.
So when you boil it all down, the journey from developer to architect is really about these key mental shifts. You stop just asking how to do something and start asking why. You stop seeing useEffect as a lifecycle method and start seeing it as a synchronization primitive. And you realize that great engineering isn't about writing perfect code. It's about making the right trade-offs.
And really, this is the core idea I want to leave you with. Look, anyone can Google the syntax for a hook. A true senior developer understands the implications of their choices. How does this decision affect performance? How does it affect how easy this is to maintain 6 months from now? It's about that architectural thinking behind the code. So I'm going to leave you with a challenge for your next code review, or even your next bit of code. After this, which pattern are you going to see differently? Are you going to be the one who spots that dependency lie in a useEffect? Or see a place where useCallback and React.memo could prevent a ton of unnecessary renders? Or maybe even identify a janky UI that useTransition could make perfectly smooth? Because the real learning, the real growth, starts right now.